Welcome to this new lesson, dear students. Today we are going to be looking at algorithm design strategies. Okay, here we are going to be looking at these different strategies we have in solving specific types of problems. There are some of the strategies which are commonly used by algorithm developers and programmers that reduces the time of execution and the amount of memory consumption, thereby leading to an efficient algorithm. Okay. Design strategies are systematic techniques for solving computational problems with common approaches. The most common ones are the one and the most used, divide and conquer. This strategy involves dividing a problem into sub-problems, recursively solving them, and then recombining them for the final answer. That we call divide and conquer. As we divide, we solve them, and we conquer them. And conquer is in a term like bringing them up together as one. D and C in divide and conquer solve problems by one, divide, breaking the problem into sub-problems that are themselves smaller instances of the same type of problem. So the first step in divide and conquer is to break the the larger problem into smaller sub-problems of the same instances of the same type of problems. After dividing, we perform recursion whereby we recursively solve these sub-problems, that is we solve them one after the other. Then we conquer, we appropriately combine the answers because the combination of the answers of these different sub-problems gives us the answer of the general problem. As you can see on this diagram, when I have a problem of size n, when I have a problem of size n, I first of all divide it into sub-problems. So I can have problem A, problem B, problem C up till problem n on B. So I can have two sub-problems, three sub-problems, or even five sub-problems. From there now, I obtain the solution of each of those problems. So this is the level of division. This is division here. After division, this is recursive, whereby we solve each sub-problem. After the recursion is done, we conquer. That is, we combine the sub-solutions for solution to the larger problem. So this is just a diagram that visualizes the divide and conquer method, whereby we break down a problem into sub-problems. We solve each of these sub-problems, and from there, we combine the answers of these sub-problems to obtain the answer of the general problem that we call divide and conquer. And this is mostly used in modular programming. Okay, we proceed. The main advantage of divide and conquer is its ability to solve problems. It gives room for parallelism and efficiency and efficient use of memory. Parallelism, it is a concept whereby many sub-problems can be solved together or simultaneously in parallel. That is one of the main advantages of divide and conquer, because as you are breaking down the problem into sub-problem, this sub-problem can be solved in parallel, that is at the same time, and it makes efficient use of the memory. But one of the advantages of divide and conquer is that it is slow due to its recursive nature. Divide and conquer is used in algorithms such as binary search, merge sort, quicksort. We are going to see all these three in the next lessons, where we shall be talking about sorting and searching algorithms. Number two, dynamic programming. This strategy is similar to divide and conquer. The main difference is that in DP, there can be an overlap of sub-problems. When we talk of overlap of sub-problems, it means that what? The output of this can be found as the input of this. By using memorization, DP reduces the exponential complexity of many problems to polynomial complexity. We are going to be exactly after this algorithm design strategy, we are going to enter inside algorithm complexity and computational theory, where you better understand about this exponential and polynomial complexity. Okay, so the difference between divide and conquer and dynamic programming is that in dynamic programming, there can be an overlap of sub-problem. Also, dynamic programming uses memorization. The major component are recursion and memorization. Whereas in divide and conquer, it is what? Division, recursion, and conquer. But in dynamic programming, the major components are recursion and memorization. That's why we say dynamic programming is equal to recursion plus memorization. Basically, there are two approaches for solving DP problems: the bottom-up approach and the top-down dynamic approach, also known as top-down approach. Now, top-down approach, breaking down a complex problem into smaller, more manageable sub-problems and solving each sub-problem individually. Designing a system using this approach is starting from the highest level of abstraction and moving towards the lower level. That's why we say top. Then we start from the top, then we move down, top-down approach. The bottom-up approach, building a system by starting with the individual components and gradually integrating them to form a larger system. So here we start at the lowest level and we take a solution of each of these lower level system and we integrate them, that we integrate these different modules, and at the end we are going to arrive at the solution of the problem. Designing a system using this approach is solving sub-problems first and then using the solutions to build up to a solution of a larger problem that we call bottom-up approach. The third one, greedy algorithms. These algorithms work in stages. In each stage, a decision is made that is good at that point without bothering about the future. This means that some local best is chosen. It assumes that a local good solution makes for a global optimal solution. So in this case, what are we talking about? We might have an algorithm that has different cases, and for a particular case we are taking our best solution and we assume that that best solution is good for the general, for all the different cases. That is what we call greedy algorithms. Number four, linear programming. In linear programming, there are inequalities in terms of inputs and maximizing or minimizing, because here we are either maximizing or minimizing a particular variable. Some linear functions of the input, so here we use inequality in terms of input and we maximize or minimize some linear functions of the input. Many problems, e.g. maximum flow of directed graphs, we are going to be looking at graphs under data type and data structures, can be discussed using linear programming. Okay, guys, you need to understand that some of these design strategies are just for you to have an overview of when or where they can be used and their definition. But some, like dynamic programming, the divide and conquer, are some of the techniques that we are going to be used when we shall be doing programming or when we shall be developing algorithms. Remember that when we were treating repetition control algorithms, I said it was part one because there are other types of repetition programs which were not treated and which are going to be treated as part two. Okay, we proceed. The fifth type is randomized algorithm. Just from the name randomized, you are making use of a random number. A few algorithms make choices randomly. For some problems, the fastest solution must involve randomness. An example is the quicksort. We use a random number in the quicksort for the efficient execution of the algorithm. Number six, the brute force algorithm. Brute force, just as the name is saying. This is a simple, comprehensive search strategy that systematically explores every option until a problem's answer is discovered. So what are we saying here? When we are having a particular problem and we have a set of solutions that can be used, we explore all those different set of solutions until we find the one that best suit the problem. Let me take an example. Imagine you have a phone that has a password, and for that password, and on that password there are only 10 possible passwords that can unlock the phone. A brute force algorithm will be used here whereby you are going to try password 1, password 2, password 3 until password 10 until we find the best password that will unlock the phone. So here we evaluate or we use all the different possible solutions until we find the one that is perfect for the problem. That's what we call brute force algorithm. It is a perfect approach to problem solving that's employed when the solution space is small to make an in-depth investigation possible. So this algorithm is one of the best when when we are using, sorry, this strategy is one of the best when it comes to problem where the solutions space is very small. That is, the different number of solutions that we can have are very small. However, because of their high temporal complexity, brute force techniques are efficient for large scale issues. Just like the phone, just take an example with the phone. A phone that takes a password, a PIN password, whereby it is a series of numbers. You can have it can be a combination of 4, 5, 6, 7, or 8. In that case, you have thousands of possibilities, and hence, in this case, a brute force algorithm cannot be used. But take an example of an algorithm where the PIN code is only 2 digits and we have only 3 digits that we can use. In this case, the brute force will be one of the best algorithm to use. But now take note also, it will be one of the best. But in case the number of trial is restricted, the brute force algorithm might not still be the best. So take note to know when a brute force algorithm is best to use and when it is not the best to use. The last one, backtracking algorithms. This technique is very useful in solving combinatorial problems that have a single unique solution, where we have to find the correct combination of steps that lead to fulfillment of the task. That we call backtracking algorithms. Very important. So such algorithms whereby you enter password 1, you move to password 2, you move to password 3. That's how I can explain it to you for you guys to better understand. That we call backtracking algorithm, whereby it has a unique solution and this solution is a combination of steps. So you need to know how these steps are structured to have the correct solution. That we call backtracking algorithms. Okay guys, we are coming to the end of this video. In the next lesson, we shall be talking about complexity of algorithms, whereby we shall see those parameters that make an algorithm to be chosen over another algorithm. Remember that when we were writing algorithms, I told you that for some problems that we had and that I designed algorithms, another program developer or algorithm developer might come out with a different algorithm, and it is only based on the complexity of the algorithms that we will choose which one is best over the other. Thank you for watching this video. Do not forget to like, to subscribe, and to share to increase our community. See you guys in the next lesson.